Hi everyone, in this video on composite functions we're going to be working through an exam question. And this question involves an unknown function which we need to find. Of course, the example we're going to be working through is the one you can see on the screen here. And if you're up for it, go ahead and press pause and try working through it before I run through the correction. If not, let's get started. So let me start by moving this question to the side, like so. And as I always do, I'll go ahead and write SOL here for solution. Here we go. We're told consider the two functions f of x which equals to x minus 3 and g of x which equals to ax plus b. We're then told, given that f of g of 3 is equal to 8 and g of f of negative 1 equals to negative 3, find a and b, where a and b are the coefficients in this function here, g of x. Now before I write down any working here, it's quite important to realize that we're trying to find two things. Indeed, we have two unknowns, a and b. The next important thing to realize is that in this question we're given two bits of information. Those being the fact that f of g of 3 equals to 8, as well as the fact that g of f of negative 1 equals to negative 3. So in summary, we need to find two things and we're given two bits of information. Now this strongly suggests that to solve this problem we're going to be making use of simultaneous equations. And indeed, the whole approach behind solving this problem is to use this first bit of information to find an expression involving the two unknowns a and b, as well as this second bit of information to also find an expression or an equation involving those same two unknowns a and b. Once that's done, we'll be able to solve this problem using simultaneous equations. So let's see how that's done. I'll start with this first bit of information here, the fact that f of g of 3 is equal to 8. And in fact, I'll copy that here. We know that f of g of 3 is equal to 8. Now to find an expression involving the unknowns a and b, thanks to this bit of information here, what I'll do is I'll start by finding an expression for f of g of x. That is, and I'll just write that, f of g of x, which I could also write as f of g of x like this. Now to find an expression for f of g of x, all we have to do is copy the expression we have for f of x, but replace every x we see inside it, so this x here, by g of x. And so that would look like this. We'd have g of x minus 3. And since g of x equals to ax plus b, well, that quickly turns into ax plus b minus 3. And so we now have our expression for f of g of x. And thanks to this, we can now find what f of g of 3 is simply by replacing the x we have inside of this expression by 3. Indeed, we can now state that f of g of 3 is equal to a times 3 plus b minus 3. And since a times 3 is just 3a, I'll go ahead and write that that's equal to 3a plus b minus 3. I carry on up here, and I use the fact that since f of g of 3 is equal to 8, and we've just shown that f of g of 3 is equal to 3a plus b minus 3, we can now state that 3a plus b minus 3 must equal to 8. And so finally, adding 3 to both sides of this equation, we obtain an equation involving a and b, which would be 3a plus b equals to 8 plus 3, which is 11. And that's our first equation involving the two unknowns a and b. And I'll go ahead and call it E1, as in equation 1. Now, as I said at the beginning, the whole idea behind this kind of problem is to get two equations like this one, which we'll then be able to solve using simultaneous equations. And so at this stage, we've used this bit of information. So let's turn to the second bit of information that's given in the question, which is that g of f of negative 1 is equal to negative 3. Using this bit of information, we should be able to obtain a second equation involving a and b, like this one. And so let me just draw a line of separation in my working here. And now we use the fact that g of f of negative 1 equals to negative 3. And I'll just quickly copy that. G of f of negative 1 equals to negative 3. And now, just as I did for the first result here, I'll go ahead and find an expression for g of f of x. And I'll go ahead and write that. So we have g of f of x, which is equal to g of f of x written this way. And now to find an expression for g of f of x, all we have to do is copy the function we have here, g of x, but replace the x that we see here by f of x. So that would be a times f of x plus b. And now since f of x is just x minus 3, we can go ahead and write this as equal to a times, in parentheses, x minus 3 plus b. And that's our expression for g of f of x. And now that that's done, we find what g of f of negative 1 is by replacing the x we have here by negative 1. And I can write that underneath here, g of f of negative 1 is equal to a times, in parentheses, negative 1 minus 3 plus b. Now, negative 1 minus 3, well, that's equal to negative 4. So that's equal to a times, in parentheses, negative 4 plus b. Finally, a times negative 4, well, that's just negative 4a. So g of f of negative 1 is equal to negative 4a plus b. And I now carry on at the top here and use the fact that we now know that g of f of negative 1 is equal to negative 3 and g of f of negative 1 is equal to negative 4a plus b to write our second equation involving a and b. Indeed, we can now state that negative 4a plus b is equal to negative 3. So that's negative 4a plus b equals to negative 3. And we now have our second equation involving the unknowns a and b. And I'll go ahead and call it E2. Now, at this stage, we have two equations, E1 and E2, involving the two unknowns we need to find, a and b. So we solve this pair of simultaneous equations. And I'll just copy them at the top here. We have 3a plus b, which equals to 11. That's equation 1. And we have the one we just found, negative 4a plus b, which equals to negative 3. That's E2, equation 2. Now, looking at these two equations, we quickly notice that they both only contain one b. And so we can use the method of elimination to eliminate it. Indeed, we could subtract E1 from E2 or E2 from E1, and that would get rid of the b's that we have on the left-hand side. And so I'll go ahead and do E1 minus E2. And in doing so, let's see, on the left-hand side we'll have 3a minus negative 4a. Well, 3a minus negative 4a turns into 3a plus 4a, which is 7a. And we then have b minus b, so that's 0. In other words, we cancel out or eliminate the b's. And that's equal to the right-hand side, on which we'll have 11 minus negative 3, which turns into 11 plus 3, which is 14. Finally, we get rid of this 7, which is multiplying the a, which we do by dividing both sides of this equation by 7. And we quickly find a equals to 14 divided by 7, which is 2. And we've now found the coefficient a. We're nearly there. I'll carry on at the top here. To find the other coefficient, b, we can use either one of the two equations we have here and replace the a that we see inside it by the value for a we just found. And so I'll go ahead and use the first equation, E1. I'll just write that. I'll take E1, and I'll say E1 with a equals to 2. I'll underline that. There we go. And so copying this first equation, 3a plus b equals to 11, but replacing a by 2, we get 3 times 2 plus b, which equals to 11. In other words, 6 plus b equals to 11. And finally, subtracting 6 from both sides of this equation, we find b equals to 11 minus 6, which is 5. And we've now found the second coefficient, b. And as such, we're done. Now, to polish things off nicely, we could of course say what the function g of x is actually equal to, and we could go ahead and state that g of x is equal to 2x plus 5. And I'd go ahead and box that result as well. There we go. Now, as such, we've now answered the question. We're done. But if ever you have time in the exam room, you could of course check the answer you just found. And to do that, all we'd have to do is check that using the function we just found, this g of x, we indeed find that f of g of 3 equals to 8, and g of f of negative 1 equals to negative 3. And so I'll quickly do that here. I'll just write check right here. There we go. And I'll start by checking that f of g of 3 equals to 8, which I could rewrite as checking that f of g of 3 equals to 8. Now, to evaluate f of g of 3, I can do that in 2 steps. The first step would be to figure out what g of 3 is. Indeed, and I can do that by using the fact that g of x equals to 2x plus 5. So g of 3 would be 2 times 3 plus 5. And so let me just quickly write that. That would be 2 times 3 plus 5, which is equal to 6 plus 5. In other words, g of 3 is equal to 11. F of g of 3 would therefore be f of 11. Let me just write that. I'd have therefore f of g of 3, which equals to f of 11. Now, f of x, remember, is x minus 3, so that would just be equal to 11 minus 3, which is equal to 8. And that's exactly what it needed to be. Remember, f of g of 3 equals to 8 is what was given to us in the question. So that result is good. And that's our first check done. For the second check, we'll check that g of f of negative 1 equals to negative 3. Well, I like to rewrite that as g of f of negative 1, which equals to negative 3. And again, we can check that in 2 steps. First of all, I'll go ahead and evaluate f of negative 1. And using the fact that f of x equals to x minus 3, f of negative 1 would just be equal to negative 1 minus 3, which is equal to negative 4. And so g of f of negative 1, well, that's just going to equal to g of negative 4. And I'll quickly write that. G of f of negative 1 is equal to g of negative 4. And so using the fact that we found that g of x equals to 2x plus 5, g of negative 4 will be 2 times negative 4 plus 5. So that will be 2 times negative 4 plus 5. We're nearly there. 2 times negative 4 is equal to negative 8. So this becomes negative 8 plus 5. And finally, since negative 8 plus 5 is equal to negative 3, we can state that g of f of negative 1 is equal to negative 3. And once more, that corresponds to what was given to us in the question. So that's correct as well. Again, this is something you would do if you have the time in the exam room, but if you do, it's a really nice feeling to be able to walk away from this question knowing that you got the correct result. There we go, everyone. I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this exam question on composite functions.